Oh, good afternoon, everyone. Actually, I've been talking, but the wrong settings were on, so I guess you weren't hearing me. Okay. I thought you guys were just being very silent. Okay. Um, yep. Okay, thanks. Okay, so what I was just saying, just to myself, was that I posted the first assignment to my e-learning, and I only want you to hand in questions 2, 4, and 5. Okay? The other questions are just like practice or something. Okay, and this assignment would be due next Wednesday. And on Monday, we'll have a chance to just go through some of them. Okay, so that you're like prepared to hand it in on next Wednesday. Okay, so any questions about that? Okay. Also, okay. Also, I'm kind of hoping that we have no internet issues today. Uh, yeah. If we do, I'll just have to figure out. I might have to uh hold these like I might have to physically be somewhere else during these sessions. I'm just hoping that Monday's class was kind of a fluke. I guess we'll see. Okay. So, so let's get back to what we were talking about on Monday. I wanted to actually record a video on this, but I didn't get a chance. But I'll just continue from where we were, and then I'll record some videos to kind of make up for the time we lost on Monday. Okay. And I hope that you have a chance to watch them before next Monday's class. Okay. So let me just remind you, we're trying to understand, like, we have this axiom, which whatever property you write down, you can get a set. And the set is those x's which satisfy the property. Okay. And it's kind of seems pretty natural, so that's good. It's like pretty easy to write down, and a lot of the sets we're interested in, you obtain by like writing down the properties that the elements satisfy. So it's like pretty natural, and also it kind of gives you all the sets that you want. Like it gives you unions and intersections and stuff like that. So and lots of other stuff. So if this axiom didn't cause any problems, we'd want to use it. So we don't use it. So let's understand why we don't use it. Okay, so we're going to assume this axiom, and then I guess the conclusion of this, I guess I should put it in quotes. The conclusion of this is then we have a contradiction. Okay, so actually what this says is that this axiom is like inconsistent with yeah, I guess we could say a better way to say it was that like this axiom is inconsistent with the only other two axioms we've written down so far, which is axiom of extension and axiom of existence. And the axiom of extension and axiom of existence are really basic. So basically, the empty set exists. That's what the axiom of existence tells us. And the axiom of extension tells us that A equals B if and only if A, B have the same elements. And if we don't have these axioms, like we can't do that much. So the problem is not these axioms, the problem is this one. So we have to like, it's too strong, we have to weaken it. So let's work out what happens. Okay, let's assume, so we assume this axiom. And what we have to do is write down a really tricky property Q. Okay. And let's let Q of X okay. Yeah, let's let Q of X it like basically we need to choose it in some tricky way. And the trick is it's going to be the property that X is not an element of X. Okay. And first we need to make sure like this is we should just say a few words on why it is, we should make sure that it's a well-defined property, you know? Because certainly if we see that you get just a second. You know, these trick ones like the one we saw on Monday, which was, let P of X be, I can write down the number X on the page, or, these like kind of tricky properties. This is just a thing that can be either true or false or both, because we know what the elements of X are, and we just ask ourselves, is X an element of X? Then Q of X is false, and if it's not, Q of X is true. Okay, so it's not possible for Q of X to be true and false, which makes it fine, so we can apply our axiom. Okay, so there exists B such that X is in B if and only if X is not in X. The axiom says the elements of B are the elements that aren't elements of themselves. Okay. And so far that seems fine, but now we kind of have a problem. Is B an element of B? Okay. Okay, and there's two possibilities. You can draw like a little diagram, yes or no. And the reason there's two possibilities, it's either X is, either B is an element of B or B is not an element of B. Well, if B is an element of B, I know that all the elements of B are not elements of themselves. So if yes, we have that B is not an element of B. Okay. That is a problem because you can't have that, like, whatever property you have, it can't be true and false. So this is a okay. On the other hand, what if the answer is no? Well, that means that B is not an element of B. Okay. Well, B is not an element of B. That's true if and only if B is an element of B. This is also a contradiction. Okay. So if B is not an element of B, then B is an element of B. Not element of B, then B is an element of B. Like, whichever one we assume, the opposite is true as well. Okay, so that's the right. So now we can write up the proof. And I mean, this is not a proof; it's just a diagram. So let's write up the proof nicely now. Okay. Okay. So there are two cases. We have it. There are two cases. Either B is in B, that's case one, or B is not in B, that's case two. Okay, now the definition of B says that Q of B is true. Q of B is just the same if B is not in B. And this is a contradiction. Okay, so that case leads to a contradiction. Case two, that's if B is not in B. Okay. Okay, and I should clarify, why do we say that Q of B is true? It's because the elements of B are those for which Q of B is true. Okay. But now if B is not in B, then Q of B is true. Since this is Q of B, so we could say this is definition of Q. And I should say like this is by the definition of B. Okay. So Q of B is true, so B is in B. This is a contradiction. That's the end of the proof. Okay, so any questions about that? Okay. So there's like, oh yes, I can show the diagram again. Just a second. Here, we have the diagram. We ask ourselves, an element of B. If it is, that means that Q of B, well, Q of B is just this. That's a contradiction. If this is not true, means this, but this is just the same as Q of B. Okay, so Q of B holds, and B is all the things such that Q of B holds, that means this. Maybe I'll try and draw the diagram with more steps in it. That help? Yeah, I'll just draw it with a few more steps in it. That won't hurt anyways. So here we have, is B an element of B? Either yes it is, or no it's not. Right, so let's just remember that Q of B, that just means, that's just a sentence, B is not, or sorry, Q of X, that's just the things, elements of themselves. And B, that's just the X's such that Q of X holds. Okay. So now, either B is an element of B or it's not. If it is to B, well, B is just the elements such that Q of X hold, the X's such that Q of X holds. So element of B, Q of B is true. Okay. If Q of B is true, well, Q of B just says that B is not in B. Okay. I'm breaking up a lot. Oh no. Okay. Let's see. That is really frustrating. Okay, let's see. Hmm. Okay, how about this? If the problem is my connection, it seems like it is. Yeah. So annoying. Okay, so my plan is finish this quick diagram, because apparently Luke is really that my internet is no good. Okay, happens, I guess. Okay. So let me just try and finish the diagram. So if B is in B, well, B is all the things such as Q of B. What is Q of B? It just says that B is not in B. So if B is not in B, is not in B. Okay, what if B is not in B? That might be fine. Okay, so if no, then B is not. Okay, what it means for the answer to be no. Okay, that means Q of, this is just the definition of Q of B. So Q of B. And if Q of B is true, well, that means that B is an element of B. That's just that by the definition of B. Okay, so if B is not in B, then B is in B. If B is in B, then B is not in B. Clearly, that's going to cause a lot of problems, right? So that's either case causes a contradiction. Okay, so like railroad tracks. Okay. Okay. So what I'm going to stop here. Over the next few days, I'm going to upload videos of the material we missed out on because of the internet, and by Monday, I will. However I do it, I'll be somewhere where you can actually hear me. Okay, so sorry for all the audio problems. Yeah, yeah. Hopefully next week this will all be in the past. Okay. So thank you again for your patience. Okay. Yep. Oh, so the element. Okay, so this question. Maybe I'll just try and type it. So is so are you sorry? So B is all the things X at Q of X. So whatever element, so if anything is in B, it satisfies Q of X. So if B is in B, Q of B holds. So yeah. So whatever, okay, so keep in mind we're setting this up to trick kind of this axiom, right? So so on the one hand, B is all the things such as Q of X. Okay. And so B is all the things that aren't elements. And we see that if B is of itself, then it's not an element of itself. And if it's not an element, then it is. And so does anyone, I can still, yeah, does that, so please say if it's not making sense, if I have, if, because I want to be able to go over it if it doesn't make sense.